Hello guys, so we will continue today on our series for solving problems using Newton's laws. Let's look a little bit closer and at these action and reaction forces that we have been talking about. Um, let's start by reading number 3 for you. A 6.0 kilogram block rests on top of a 7.0 kilogram block which rests on a horizontal table. What is the force, magnitude, and direction exerted by the 7 kilogram block on the 6 kilogram block? So, in order to save some time, I have drawn here your two blocks. You have a red block that's supposed to be the 6 kilogram one, and so we will decide that this red block has a mass mr for red, which is 6.0 kilograms, and then the green block mg for green, that's a mass of 7.0 kilograms. And the very first thing that the problem asks is, what is the force exerted by the green block on the red block? So if you look at it from a perspective of vectors, what you will see is that this is an interaction caused on the red block like this. Now you know from third law that there is a corresponding interaction on the 7 kilogram block, but we're not discussing that yet. What we are talking about is that this is the force exerted by the green block on the red block. This is, of course, the force exerted by the red block on the green block. But again, we're not discussing that yet. What they want you to find is what is the force of the green block on the red block. So let's go there with a free body diagram. The whole idea is that you have basically two forces on this red block. One of them is your usual mass times gravitational acceleration. It's mass of the red block, so mr g, and the other one is a normal force. And a very close look at your diagram tells you that this normal force is nothing other than the force exerted by the green block on the red block. Now, if on top of that we see that this is an equilibrium situation because the block is not accelerating, then what you have is that the sum of the forces in the y direction is 0, which means the force exerted by the green block on the red minus the mass of the red block times g is 0. And this, of course, tells you that the normal force, or the force exerted by the green block on the red one, is 58.8 newtons. You just have to plug in the numbers, m times g. So that's your answer for letter A. How about the second part, part B? They request now, what is the force? Oh, sorry, this is upwards, because of course the green block is supporting the red block. Now, what is the force, magnitude, and direction exerted by the 6 kilogram block on the 7 kilogram block? Well, you don't need a new free body diagram for that, because you have your third law, and your third law tells you that these two things are an interaction pair. This is the force exerted on the red block, this is the force exerted on the green block, and the third law tells you that they are supposed to be equal in magnitude and opposite in direction. So force exerted by the red on the green is the opposite and same magnitude as the force exerted by the green on the red. And of course, we already know that second one because we just found it. Green on red is 58.8, which means that your force exerted by the red block on the green block is equal to negative 58.8 newtons. And just this negative basically means that the force is pointing downwards. So that is a direct application of Newton's third law for you. Thank you very much for watching. See you later.